guys, and welcome to 10.2. We're going to continue working with exponents today. And today you guys are going to look for mathematical patterns to help you solve a problem. So you're going to be engaging that logical part of your brain that's able to see repeated reasoning and find those patterns. So I hope you find this pretty fun. So the first thing we're going to do is we're going to talk about whether you have a similar base or not. So if we have 2 to the second times 2 to the fourth, when we are talking about the base, we mean this number that's raised to some power. So here we do have the same base. So when you are multiplying the same base, what you end up doing is adding your exponents. So this would end up being 2 to the sixth. And you may say, what? How in the world can you add when you're actually multiplying? But let's take apart what this actually means. This would be 2 times 2, right? Times 2 times 2 times 2 times 2. Okay, so if we were to multiply all these together, we would end up having 2 multiplied by itself 6 times. So do you see how that works? If you have the same base, you add exponents. So would that help us solve this one? Our first question is always, is the base the same? Here, our base is 3, here our base is 4. So no, we can't use the product of powers to solve this one. So let's see if we can write a more general statement for this. If we have a raised to the m power times a raised to the n power, what will that equal? You are right if you said a to the m plus n power, because they have the same base, so we're going to add exponents together. Now we're going to look at a situation where we have an exponent, or we have a base and an exponent, so we have an exponential expression raised to a power. So let's just look at what this is actually saying. So we would have 3 times 3, 3 times, right? So this is what it would look like. Okay, because this broken out is just saying 3 times 3, or 3 squared. And this power up here is telling us that we have that times itself 3 times. 1, 2, 3. So if we look at the number of 3's over here, we see that that ends up being 3 to the sixth power. So let's look back at these powers here. When we have a base raised to a power, and that whole expression raised to another power, we are going to end up multiplying exponents. So if we were to look at that in general form, if we had some number raised to the a power and that whole expression raised to the b power, it would end up looking like x to the a times b. So that's called the power of a power property, telling you that you have to multiply exponents when you have an exponent raised to another exponent. So real quick example, if you had x to the fourth squared, that would end up being x to the eighth. So in some of your work today, you are going to find where they have two numbers multiplied together raised to an exponent. So if we were to write this, it would look like 2 times 3, 3 times. And what you can do is you can actually pull out how many times do I have this base, because they're all multiplied together, right? So we're on a level playing field. Everything's multiplied together. So we can play with how we're writing it. So we have this base 3 times. So we can rewrite that as 2 to the third power. And we have 3 times. So we can rewrite that as 3 to the third power. And then you could evaluate. Sometimes they'll ask you to just leave it right here because they're getting you used to playing with these exponents. So just a quick review. If we had 5 squared times 6 to the fourth, can we use the product of powers property? Our first question is, do we have the same base? So no, we don't have the same base. We can't use that. That's not going to help us here. So just a quick review. If you are multiplying two things together, let's say we have -4 to the fifth times -4 to the seventh. If you have the same base and you're multiplying them together, you can add exponents. Only if you have the same base and you're multiplying them together. Okay? If you have a power of a power, let's say we have -3/4 raised to the 5th power, and that whole thing is squared, you will multiply exponents. So that would end up being -3/4 to the 10th power. So to wrap up our day, we're going to just look at number 28 out of the book. It says the lowest altitude of an altocumulus cloud is about 3 to the 8 feet. So that's the lower limit. And the highest altitude of this type of cloud is 3 times the lowest altitude. So we take this 3 times, okay? So what is the highest altitude of an altocumulus cloud? Actually, I wrote that wrong. We're going to talk about that. It would be 3 times this, okay? So if this is equal to 3, 8 times, and this is 3, how many times would we have that 3 there? Our final expression would look like this, 3 to the 9th. So that is the top height of an altocumulus cloud. And our bottom height would be 3 to the 8th, and that would be 3 to the 9th. So enjoy some sunshine today and have fun with powers and exponents.